Now we are on calculus. You know calculus is very wide. So we have limit and continuity of functions, we have differentiation, we have integration, we have differential equation. So there are many more like that. So calculus is very wide, but we'll be starting with limit and continuity of functions. Limit and continuity of functions. But before you can solve any limit question, you have to know that it has some indeterminate forms, or we call it undefined forms. You have some indeterminate form, or we call it undefined forms. And what are the indeterminate forms? You must not have 0 over 0. Those are the indeterminate form. You must not have 0 over 0 when solving. You must not have 0 raised to power infinity. You must not have 0 raised to power infinity. You must not have infinity over infinity. You must not have infinity over infinity. You must not have infinity raised to power 0. You must not have infinity raised to power 0. You must not have infinity minus infinity. You must not have 1 raised to power infinity, and you must not have 0 raised to power 0. So these are the indeterminate form, or we call it undefined forms. So please take note of all this. Whenever you are solving limit, you must not have all these kind of forms in your solution. So whenever you have all these kind of forms in your solution, meaning that you have to use another approach to solve it. And there are different methods you can use to solve a limit question. Different approach. I think we have up to like 5. So we'll be solving different approach under limit and continuity. But today's approach will be what? Just only one method. I will only use one method, which is the simplest one, which is the direct approach. Shall you understand? That's the direct approach. So I'll solve now question 1, you solve question 2. The question on red, you solve it. I'm solving question 1. So you give me the answer for question 2 in the comment section. So example, evaluate the following. Question 1 says limit as x tends to 2. X tends to 2. 3x squared minus 5x over x plus 6. While your own question 2 is limit as x tends to 1. Square root of 3x squared plus 1. Square root of 3x squared plus 1. So you give me the answer in the comment section. So number 1 now, I'm solving number 1. Solution. Limit as x tends to 2, 3x squared minus 5x over x plus 6. Now, don't forget, the first thing is to what? Insert your limit and check. Once it doesn't give you an indeterminate form, then you are good to go. Shall you understand? Because our aim under limit, don't forget, take note of something. Our aim under limit is your denominator must not be 0. That's your aim under limit. Whenever you are solving any limit question, your denominator must not be what? Must not be 0. Put that one at the back of your mind. Your denominator must not be 0. Now, let's just insert as x tends to 2. Meaning anywhere we see x, we put 2. Now let's insert. That will be what? 3 into bracket 2 square minus 5 into bracket 2, abi? Then over 2 plus 6. So this one now, 3 into bracket 2 square, what will you do? You leave 3. Then you first solve for 2. 2 square will give us what? 4. Don't go say 3 times 2 6 and say 6 square. No, it's wrong. Oh. The square is for 2, so you leave 3 first. Then 2 square is what? 4. Then minus 5 into bracket 2 over 2 plus 6 will give us what? 8. 3 times 4 will give us what? 12. Then minus 5 times 2 will give us what? 10 over what? 8. What are we going to have? That will be giving us what? 12 minus 10 is what? That will give us 2 over 8. And we can reduce it. 2 here 1, 2 in 8, 4. So meaning that our answer is what? 1 over 4. This is what we call the direct approach. Just direct. You see that when we put it, our denominator does not give us what? 0. So solve number 2 and give me the answer. Tell me the answer in the comment section. Please don't forget to subscribe, like, and share this video. Thank you.